have your second tab that says on step 2, borrow from the whole number. This is going to go on the right hand side of page 68. So we're going to talk about subtracting mixed numbers with borrowing. Our problem for this is going to be 7 1/6 minus 3 5/12. Our very first step, like we do with every single fraction problem, is we just observe it. And what do we observe about this problem? Hopefully we're observing that it's a subtraction problem. Our denominators aren't the same and we have mixed numbers. So because we know it's a subtraction problem, we also know that our denominators have to be the same in order for us to solve this problem. So that means that our next step has to be to get these in the same place. And so our next step, just like on the previous one, is going to be to find the least common denominator. So we're going to find our least common multiple, and in this case we call it our denominator because that's the place that we're going to put it in. So we have 6 and 12. That means we're going to do what kind of counting? We're going to do skip counting. We're going to start with 6, and we'll go 6, 12, 18, 24. Some of you might have said stop right here because we know that the first multiple for 12 is 12. And that is what they share. So our least common multiple, or our least common denominator is going to be 12. That means that our next step is we are going to change our problems into equivalent fractions where our denominators are 12. So step 3 is we are going to rewrite the fraction. And we're going to make sure we do not make a common mistake and forget the whole number. So we're going to drop down our whole number first. And we know that we're going to change our denominator to 12ths. And it's subtraction. We have 3. We're going to change this denominator to 12 as well. So here we have to stop and we have to think. How did we get from 6 to 12? Well, if we did this work right here, we should know that we multiplied it by 2. Also, if we know our multiples of 6, it becomes a lot easier for us. So we know that 6 times 2 equals 12. Well, one of our golden rules of fractions is whatever we do to the denominator, we have to do to the numerator. 2 times 1 is 2. Then we look over here and we think, how did we get from 12 to 12? Well, we multiplied it by 1. Does 1 change anything? So do we have to multiply this by 1? No, we could just drop this fraction down, untouched, completely, just exactly how it was in our original problem. Now that we've rewritten our problem, our next step is going to be to observe it. Because we changed to equivalent fractions, so we have to see, do we even need to borrow? And look at all of that. So we look here and they're both have the same denominator, so we could solve this problem. But we look and can we take 5 away from 2? If I have 2 pieces of candy, can I give you 5? If I have $2 and you ask for 5, can I give you $5? No, so what we're gonna do is borrow, just like we do when we have whole numbers. We're gonna go to our place value. We go to our place value in front and we take a group of 10 out. We're going to do the same thing here. So our step number 4 is we are going to borrow from the whole number. So we're going to borrow from our whole number. What our whole number really represents is 7 groups of 12 twelfths. Seven. That's what it means. It means that we had 7 groups of 12 twelfths. And the reason why we know that it's 12 is because our denominator tells us that that's how many pieces our wholes are split into, is 12. It'd be like if we had 8 circles and they were all split into 12 pieces, 7 of them would be completely colored in, and on the last one, only 2 pieces of the 12 would be colored in. So we're going to take one of these groups of 12, one of these wholes out of our 7, and we're going to take it out in fraction form. So we're going to borrow one of these guys. We're going to bring them down here. We're going to go 12 twelfths, which is 1, plus 2 twelfths. We are not going to do anything to this number over here, because if we went to borrow, we would still have to keep borrowing from this side. So we're not going to touch this number at all. It's going to stay the way it is. Our 7 is now going to become a 6, because we now only have 6 wholes here, because we pulled out 1 and we're adding it to our fraction. So now we're going to have 6 as our whole number. We're going to go 12 plus 12 is, or 12 plus 2 is 14. I'm going to go 12 plus 12 is 24 as my denominator. Hopefully we're saying no, because golden rule, for one of our second golden rules of fractions is we never add or subtract the denominators. So our denominator stays the same. Then we just drop this number down. We observe it again. Can I solve this? Can I take 5 away from 14 now? So that's going to be our final step. Is we are going to subtract. So we're going to subtract our fractions first. What is 14 minus 5? We should say 9. We go 12 minus 12. Just kidding. Our denominator stays the same. Then we look at our whole number. 6 minus 3 is... Now that we have an answer, what do? We stop and we observe it again. Because we want our answer to be in our best answer possible, our championship answer. So what we observe about this is that we have 9 twelfths. Do we think we could simplify it? So let's try. What that means is we have to find the factors of 9 and 12. So we're going to find the factors of 9. We have 1, 2 doesn't go into 9 evenly. We have 3. Oh, 3 times 3, there's our baby rainbow. So now 1 times what equals 9? 9. Then we have 12. We go 1, 2 goes in there evenly, 3 goes in there evenly. Oh, 3 times 4, that's my baby rainbow. 2 times 6, and 1 times 12. Well, because I'm looking for my greatest common factor, I'm going to start at my larger numbers. Well, 12 can't go into 9, 9 can't go into 12, 6 can't go into 9, 4 can't go into 9, but 3 can, and 1 can. We want our greatest one, and that is 3, so we are going to divide 9 and 12 by 3. And the reason why we divide both the numerator and the denominator is because of our golden rule. Whatever we do to the numerator or denominator, we have to do to the denominator or numerator. So now we're going to drop down our 3, because we didn't do anything to that. And we go 9 divided by 3 equals, and we go 12 divided by 3 equals. Then we stop and we observe it again. What do we observe? Hopefully we recognize that 3 is a prime number, and 3 cannot go evenly into 4. So this is our best answer. 7 1/6 minus 3 5/12 equals 3 3/4. And that is how you subtract mixed numbers with borrowing.